And this is part of 3.7. Our topic 3.7 is on transformations of polynomial functions. In this topic, or this section, we're going to talk about even and odd functions. Now, I know in topic 3 we have a lot of even and odd. You had even and odd end behavior. We looked at even and odd multiplicity. Now we're looking at even and odd functions, which refers to symmetry. So don't confuse even and odd here with the even and odd end behavior. They are similar, but there are some differences. So here we go. An even function is going to be symmetric about the y-axis. So notice if I have points, they're going to be equidistant from the y-axis. So for any x, y, my values, my new values on the other side would be the opposite of whatever x is, but my y value would stay the same. And here's an example. If you start out at 2, 3, you would be at negative 2, 3 on the other side of the y-axis. Here's going to be our test, and we're going to come to that in a little bit. So f of x is going to be equal to f of negative x. Now here with odd functions are symmetric about the origin. You kind of see it's almost like a reflection. What's going down here, something's going on in quadrant 1. Something's also happening that looks very similar in quadrant 3. And your x and y coordinates, well, they're just going to change signs. So, and here is going to be a rule. If we do f of negative x, so we plug in negative x, what's going to come out is the opposite of f of x. So all of your signs will flip on your original function. If it is neither, you would have no symmetry about the y-axis or origin. And when we do our test, if only some of the signs change, when we input negative x, it's going to be neither even nor odd. Now, again, going back to that idea of the difference between even and odd functions and even and odd end behavior. As you can see, this function has even positive end behavior. However, and this is an even function. If I were to give this a horizontal shift, either right or left, this would no longer be considered an even function because it is no longer symmetric about the y-axis. Same here. If I were to do a horizontal translation, maybe horizontal, vertical, it is no longer going to be symmetric about the origin. Right now, this is odd positive. It is an odd function. If I translate it, it would still be an odd positive function, but it would not be an odd function because it is going to be missing that symmetry. Let's do a few examples. So here's going to be our algebraic test. And what you're going to do is you are going to substitute negative x in for x. So I'm going to take f of negative x equals 4 times negative x raised to the 4th power plus 5, and let's just evaluate. Well, any number that's negative, if it's raised to an even power, it's going to be positive. 4x to the 4th plus 5. Now notice, none of my signs changed, so that means I have f of negative x equals my original function. This is even. Now on this one, f of negative x, 2 times negative x raised to the 3rd plus 3 times negative x. If I raise any number, or negative number, excuse me, to an odd degree, this is going to stay negative. I have negative 2x to the 3rd. 3 times negative x is negative 3x. Okay, when you compare it to the original, notice both signs changed. F of negative x equals the opposite of whatever f of x was. So your signs just flipped. It doesn't necessarily mean that they came out negative, but your signs flipped. This is odd. Take a look at this one. F of negative x, 7 times negative x raised to the 5th minus 2 times negative x squared plus 4. Okay, negative number raised to an odd exponent, this stays negative. Negative 7x to the 5th. Negative x squared, okay, even number, this is going to go positive. I have negative 2x squared plus 4. So if you look at this one, notice my first term changed signs, my second one did not, and my third one did not. So it's either even, all signs stay the same, odd, all signs change, neither. Some changed, some didn't. This one is neither.